Hello everyone, we are the team FE Liners. I am Farhana and my teammates are Nandini and Shravani. In today's data-driven banking environment, decision making requires a unified view of customers, transactions and risk. So, in this project, we built LakeSheild-360, an end-to-end lakehouse platform that transforms raw financial data into actionable business insights. The goal of this project is to provide a customer 360 view along with risk analysis, loan decision, branch performance insights using modern data engineering practices. In traditional banking systems, data is fragmented across multiple systems. Customer data, accounts, loans and transactions are all stored separately. Because of this, banks face challenges like no unified customer view, poor risk assessment, inefficient loan approvals, lack of branch level performance insights. This leads to delayed decision and increased financial risk. The tech stacks we used in this project are Databricks, PySpark, Delta Lake, Delta Live Tables and also Power BI for interactive dashboards. Next, we are diving into the medallion architecture. To solve this problem in a scalable and structured way, we designed our system using medallion architecture. This architecture organizes data into three layers: bronze, silver and gold. In bronze layer, we ingest the raw data exactly as it is received from source systems. This ensures that we preserve the original data for traceability and auditing. Next comes silver layer. We clean and standardize the data. This includes handling missing values, removing duplicates. This will be further explained by my teammate. Finally, we reach to the gold layer. We transform the clean data into business-ready data sets. Also, here we come to the data sets we used. We used mainly 4 tables, that's customers, account, loan, transactions. Transaction has across 50,000 rows in it, records in it, which captures financial activities like deposits, withdrawals and transfers. Now I'll show you the pipeline. This is the pipeline we built. Here you can clearly see we used 10 tables these are mentioned over here, and here comes the bronze, this is the silver and this is the gold. This everything, each and every part will be further explained by my teammate. Thank you. Okay. Hello everyone, I am Nandini. In bronze layer, we have done data ingestion using delta tables, using PySpark and Delta Live tables. At this stage, we have not applied any transformations, and to preserve the original data, just we loaded the table using the function read CSV, and we have mentioned all the things that we want to load, and we have loaded all the 11 tables. And coming to the silver layer, in silver layer, firstly in customers table, we have read the customer bronze table and we have dropped the duplicate values, and we have reformatted the date of birth from year, month, date to month, date, year. And we have filtered if it is not null of the customer ID, then only we have taken all the values of the table. In accounts table, we have dropped the duplicates, and we have also converted from year, month, date to month, date and year format, and we have filtered using if it is not null only we have loaded the data. And coming to loan silver table, we also did the same thing, removing the null values and changing the date format from year, month, date to month, date and year. And estimated end date also we have done that from year, month, date to month, date, year. In transactions table, we have filtered the columns based on amount greater than 0 and the timestamp from year, month, date to month, date, year. And we have filtered the transactions table. If it is not null only, we have included that rows, and in all other tables we have drop the duplicates values. Coming to next, we going to goal layer. In goal layer, firstly we have read all the customers table, accounts table, loans table, transactions table from the silver layer, and we have taken transaction aggregate function using group by of the account origin ID, and we have performed aggregate functions such as count, sum. And coming to next, we have created a data frame with join using join of the customer accounts, loans and transaction aggregations, and we have returned that value that was present in the customer 360. And further way of explanation of customer 360, we have used this data. And in risk analysis, we have read the customer 360 goal layer table, and with column risk level we have taken the principal amount. For example, if we have a bank account, in that we have an amount of 20,000, and we have a loan repayment of 1 lakh, then how can we think they can pay the loan amount? That is, we have segregated here in risk analysis. Coming to loan decision table, we have if there is high risk level, then we have rejected. If I have medium risk level, we can review the application, and otherwise we approved it. In branch-wise performance, we have loaded the transactions table, accounts table, loans table from silver, and we have joined the accounts and loans, and we have performed group by sum and count distinct, count star, sum in this table in gold layer. In best branches also, we have derived from the best branch performance gold layer, and we have performed performance score, and we have ordered by descending order. Then we have retrieved the top values, loan eligibility, and also we have uh, we have loan eligibility goal. In that, if the risk level is low, then we can like how much eligible amount that we can give to a customer, that was rendered here. This is what we have done in these 3 layers. Thank you. Next will be continued by my teammate Shravani.
Hello, I am Shravani. To conclude, this project demonstrates how a modern data engineering approach can transform fragmented and unstructured banking data into a unified, reliable, and insight-driven platform. We started with a raw data spread across multiple entities such as customer, accounts, loans, and transaction, and systematically processed with through a structured Medellin architecture. By implementing the bronze, silver, and gold layers, in the goal layer, we build key analytical datasets such as a complete 360 degrees view of customer, risk classification models, loan approval decision logic, and branch performance metrics. The output stimulates real-world banking intelligence system where decisions are not made on raw data but on processing reliable and context insights. On the visual side, we have successfully established connectivity between Databricks and Power BI. This integration ensures that all our goal layer datasets are readily available for building interactive dashboards and real-time reporting. While the dashboard development is currently in progress, the most crucial part, which is the data pipeline transformation logic and system integration, has been fully completed. This means that the business users can directly connect through the system and start building analytical reports without any additional data preparation. Coming to business value, from a business perspective, the system enables faster and more accurate loan decision making, early identification of high risk customers, and performance evaluation across branches. Coming to future scope, looking ahead, this platform can be further enhanced by developing advanced dashboards with drill down capabilities, integrating real time data streaming for instant insights, and apply machine learning models for fraud detection, predictive analysis. And the final impact, in essential, LakeSheild-360 is not just a data pipeline, it is a scalable decision support system that transforms raw financial data into meaningful and actionable insights. Thank you.